Well, hi everyone. My name's Pete Muddle. I am the Deputy Principal at St Philip's Christian College at Gosford on the Central Coast. And for last year's Mathematics Advanced High School Certificate Examination, I was responsible for questions 19, 20, 24 and 27, alongside Margaret Clemson, who we worked together on our group in this area. And I'll be also looking briefly this afternoon at the multiple choice section, which I'm going to begin with. Okay, so question one, which of the following is equivalent to sine squared 5x? And you can see the options there. A good opportunity for students to demonstrate their understanding and application of trig identities. I won't be going through the answers. They're available on the NESA website, but just talking a little bit through these. Thank you. With question two, some of the newer content to the course, an opportunity for the students to demonstrate an understanding of expected value. And so this question asks them to calculate that given the information in the table. For question three, students were asked to represent the domain of the function f of x equals natural log of 1 minus x. And so the students needed to deal not only with a logarithmic graph which had been moved around, but also needed to demonstrate an understanding of the correct bracket and parentheses notation for demonstrating their understanding of domain. And so there were a few things at play there. And as you'll see through the multiple choice, the questions tend to become more increasingly difficult. In question four, the students needed to determine which of graphs A to D best showed the cumulative number of downloads up to and including each day based on a normal distribution, normal shape distribution at the start of question four there. And so an opportunity for them to demonstrate that, and they had to show their knowledge and understanding there. In question five, the students needed to work out which of the following best represented the graph of y equals 10 multiplied by 0.8 to the power of x. And although we don't see the student working, we'd imagine that students would first need to work out where the y-intercept was in order to consider the shape and of the curve beyond their initial understanding of where it hit the y-axis. And so students would be encouraged to potentially use their existing knowledge of exponential curves, or possibly to look at what it might look like to find a few additional points, and that would make that question much easier to solve. In question six, we have a probability question for the students to consider, where they needed to look at whether or not this question included an independent event or a dependent event, and also for them to then work out if the and or situation, which many of us would teach our students. And so this question, if read carefully, could be solved well by the students in this course. For question seven, the students had to demonstrate an understanding of the value and the sign of a y value, a first derivative, and also a second derivative. And so there was an interesting question to be solved here about which had the greatest value, least to greatest value of the function at a certain point, as opposed to the derivative at a certain point and the second derivative. And so students could demonstrate their understanding if they were able to interact with this question well. Getting towards the end of the multiple choice, and the questions are becoming much more difficult now. In question eight, the students needed to pick from A to D which was the best equation for the graph. And so they would demonstrate their understanding in particular of intercepts, and then also what would happen for a cubic point as opposed to a point with the power of 1 in the bracket, to work out which one of those was the correct response. And so students would need to demonstrate a few things, as you might expect at this higher end question in the multiple choice. And then we move to questions 9 and 10. And this one here was quite complicated. And one of the things that made it more complicated was that they were working on the equation y equals mx plus c. So there wasn't a lot given away about how to calculate the tangent. And so they really needed to demonstrate an understanding of odd and even functions in order to work this one out. And I imagine that this one was quite a tricky one for students because they were putting together the idea of f of g of x, and then to understand what would happen to the tangent at a different point. And so there was some high order thinking that was required in order to correctly answer this question. And finally, in the multiple choice, we have a situation where the line mx is a tangent to a curve y equals cos x, and students at that point would be able to work out where the end of one wave was to get an idea of the y value. But then what they need to do is to work out which of the following statements is true, to look at what is the value of a. So what is the value of 1 over a? And does that exceed, or is that smaller than the 1 over 2 pi and the other things that they were looking at there? And what is the value of y equals mx, in particular, looking at the gradient? What is the value of m at that point? And so there were a number of things that students would need to look through. And so those last few questions in the multiple choice would really work out who understood the maths that they'd been taught in class really well. Well, that's the multiple choice. And so, albeit very brief run through, I'd encourage teachers to spend time working through questions of a multiple choice nature, because you can never get too much practice, in my opinion. But let's have a look at the questions which were looked at by the group that Margaret and I were responsible for in much more detail. So we'll start with question 19. And I loved this question. It encouraged the students to demonstrate an understanding of graphing, in particular, a hyperbola, in order to graph y equals 2 plus 1 over x plus 4. And students were specifically told to show asymptotes as well as the x and y intercepts. And so in this question, students should have calculated the intercepts of the hyperbolic function on the x and y axis. They were required to identify horizontal and vertical asymptotes. We'll come back to that in a minute. They were also asked to carefully sketch. And so there was an element where we cared about the quality of the sketch there, making sure that the important information was there. And so as we work through this question, the feedback from our marking team was that significant areas for improvement included students who forgot to label essential features on their graph. They may have thought about moving across and up a hyperbolic graph, but they might not have labeled them or indicated in any way what those values were. Students would sometimes not carefully enough draw those hyperbolic branches, and they would cross the asymptotes, which is something you don't want to see on a question like this. Areas for improvement also included taking care to avoid arithmetic errors with positive and negative values. And other areas of improvement included using a ruler to draw the axes and asymptotes on a sufficiently large diagram. When students wouldn't draw a large enough diagram, we found that became problematic, especially for hyperbolas drawn freehand. In better responses, students were able to draw a hyperbolic graph, labeling intercepts and asymptotes. They were able to perform the task. Wonderful. They were able to sketch a hyperbolic shape with the branches approaching the asymptotes, I might add, and not crossing them. And they were able to demonstrate an understanding of vertical and the horizontal shift of a basic hyperbola. And it was great to see that done really well. The next question we looked at was question 20. For the values of x in the interval of 0 to x to pi and 4, for what values does the line y equals 1 intersect the graph of y equals 2 sine 4x? A wonderful opportunity for students to demonstrate not only an interaction with the question to show that they understood what the question was asking of them, but also the ability to solve a trigonometric equation. And so in this question, students should find the intersecting points between two functions. They need to consider the given domain had more than one solution. On this occasion, had two solutions, and they needed to give their answer using radian measure. And so areas for improvement that we found was that students needed to find solutions that satisfied the given domain. Areas for improvement include appreciating the question was asking for values of x rather than just how many solutions there were. Students could improve by leaving final values in radian measure, and some of them would start in degrees, but finishing in radians was really important. Students referring to a graph in this particular question does not necessarily imply a graphical solution. We wanted them to show us the answers, not simply draw a graph of the sine function, a graph of y equals 1, and show that there were a certain number of answers. We wanted them to be found. And final area of improvement that we identified was sketching a graph would find the number of solutions. So students could find that a helpful thing to do, but they needed to make sure they then went on to actually find the answers. Now, in better responses, students would start by forming the equation 2 sine 4x equals 1. That was the first part of the question that I was referring to, that they would understand that y equals 1 and y equals 2 sine 4x could be solved simultaneously, in a sense, to get them to the answer. And they would then essentially find the question easier if they made the domain 0 to 4x to pi, and then to ultimately solve 0 to x to pi on 4. In better responses, students were able to solve the trigonometric equation within the specified domain, i.e. cancelling out any incorrect answers. And then if they were able to show their working to find the related angles, they were more likely to finish the question well. Question 24. Now, in this question, the students needed to demonstrate their understanding of finding areas by integration or otherwise, because there were a few different ways to get part of this solution, and they needed to work out the exact area as indicated in the diagram. They were given a point of intersection. They were also given the bound x equals 4, and they had to work out the exact area. And so many students were able to identify that this was a question best done by splitting the area into 2 parts, but we'll have a little look at what the feedback was. So students should determine the area of a shaded region by solving indefinite integrals. So there was an integration aspect. They would divide the shaded region into 2 shapes, although there was more than one way to do that. To calculate the area of each shape using integration or geometric ideas, and then to label the diagram to assist with calculations. Those things were all parts of a successful end to the process. Areas of improvement certainly included an understanding that the primitive function of y equals 3 over x minus 1 would lead to a logarithm. There's some work to do there. But also to show that showing the substitution of the upper and lower boundaries into the antiderivative. Some students tried to skip over that part or do it too quickly, and hence were unable to successfully complete the question. The good news is, though, in better responses, students were able to interpret the shaded area as a combination of a triangle and then an area under a curve. Students who did that were able to get along the way to solving the question. That was great to see. Students were able to integrate the hyperbolic function between x equals 2 and x equals 4 to obtain the logarithmic expression, and then to substitute upper and lower boundaries into that logarithmic expression, and then to add the 2 areas in order to find the shaded region. And it was great to see so many students applying their integration skills beautifully in order to complete that question. Okay, the last question that our team looked after was question 27, which is in 4 parts. And it is a story of someone called Kenzo, who ends up doing some charging of a mobile phone. And so a big part of this question, as you'll see later on through it, is understanding exactly what the question was asking. And you'll see that shortly. But in part A, the students were asked to sketch the graph of 400 sine pi over 12t between 0 and 12 in order to earn 2 marks. And so in this, students needed to state the amplitude of the function as 400, to calculate the period of the function as 24 hours, although they were asked to draw the graph from 0 to 12. They would draw a sine curve starting at the origin, and they would label the amplitude and the related time in order to do this well. Areas for improvement. Students should ensure that they sketch a sine curve with the correct concavity. It's really important. And that was an issue for some students. Students would find values for time in radian measure, really important to make sure that they're working in the right units. And then to develop an understanding of period and amplitude when sketching trigonometric functions. And it was done really well on the whole, but certainly some areas for improvement, especially when students are only used to drawing graphs, which are done in terms of units of pi along the x-axis. But in better responses, students were able to sketch a half period of the curve from 0 to 12, showing the amplitude, labeled correctly the horizontal and vertical axes. That was great to see. Sketch a smooth curve depicting a sine wave, and then use the space provided to sketch a sufficiently large graph. This has come up a couple of times in this section, the questions that we looked after. We want students to ensure that they are drawing a good sized graph in order to complete this task well. Quick question 27B, we had a show question. The students were told that power is the rate of change of energy, and then told that that the amount of energy generated by the solar powered phone charger could be given by E as the integral of PT to T. And so the students in this question needed to show that E equals 4800 over pi cos A pi on 12 minus cos B pi on 12. And questions that are show questions are always a little bit fraught with danger when students assume steps but don't demonstrate how to get through the question. And so here's a few things that are worth noting. So students should set up the integral initially, start with P of 2 and integrate it. And they would use the reference sheet as a guide, as there was a lot of helpful things there. They would state the additional coefficient, which comes out the front as minus 12 on pi after integrating, and then show the order of substitutions of the upper and lower boundaries. Again, they were given the answer. We wanted them to show us how they got there. And so some areas for improvement, you probably picked it already, is making sure that students show every step of the working. Also, that understanding into the integration result is the primitive function value after the substitution of limits. We wanted to see that done well, methodically, clearly, and carefully. To use the formula that the integral between b and a of f of x dx is f of b minus f of a. And another area for improvement is in taking care when multiplying and dividing with fractions. That was really important. Well, in better responses, students were able to rearrange the integral by taking 400 out the front. That seemed to make the question easier to solve. That they would find the correct primitive function, and then they would show the substitution of A and B. And if they followed those 3 steps, students were generally more able to get this question right. Question 27C, there was a little bit to interpret here, wasn't there? To make a phone call, a phone battery needs at least 300 units of energy. Kenzo woke up 3 hours after sunrise and found that his phone battery had no units of energy. He immediately began to use a solar-powered charger to charge his phone battery, find the least amount of time he needed to wait before he could make a phone call, and give your answer correct to the nearest minute. It was interesting, the number of students assumed, certain things about when Kenzo may have woken up as part of this, but there was a bit to interpret there. And so students needed to substitute A equals 3 and E equals 300 into the equation in part B, and then solve the trigonometric equation using radians. And their job at the end was to answer to the nearest minute. And so there's a few areas where students could have improved. They could improve by carefully reading the question to identify the appropriate substitutions. There were students who put incorrect numbers into the limits in the question and had trouble finishing it. They would equate the rate to P of T and the energy to E of T. So there's an area for improvement in misinterpreting certain parts of the question. Developing skills to solve resulting equations involving multiple trigonometric and arithmetic calculations. Practicing algebraic manipulations of trigonometric equations. And finally, using exact trigonometric ratios and simplified fractions when solving complex trigonometric equations. There was a lot of work to do in this particular question, and it was not an easy one. It was not an easy one. Well, there were some students who did this question really nicely, and in better responses, students were able to substitute in the correct values for A and E into the equation in part B. It got them on their way. And then they were able to perform arithmetic and trigonometric calculations to find B as 3 hours and 57 minutes, and then to subtract 3 hours to find the minimum waiting time. And so students who were able to follow those steps tended to be more successful in finishing the question. All right, we're on to the last part of the last question here, part D, and this one was it really polarized the students in the sense that it was either understood quite well, or students may not have had the opportunity to interact if they weren't able to access the question. But having a look here, it says, the next day, Kenzo woke up 6 hours after sunrise and again found that his phone battery had no units of energy. He immediately began to use his solar-powered charger to charge his phone battery. Would it take more time or less time, or the same amount of time compared to the answer in part C, to charge his phone battery in order to make a phone call? And specifically, explain your answer by referring to the graph drawn in part A. So students need to interpret their graph from part A to formulate an answer, and then to state that P of T had a maximum charging capacity when T equals 6 hours, which is more than the charging power at T equals 3 hours. And so we wanted them to get to that stage. And of course, if they had a good response at part A, it made that much easier. And so some areas for improvement, understanding the question. And for some students, it'll be tackling more questions with worded problems, and that will certainly serve students well into the future to ensure that they're doing lots of worded problem questions to assist them. To refer to the original graph in order to compare the times being considered in the question. Another area for improvement is stating a reason to support their answer in relation to the graph. And then in referencing the power in the graph rather than the sun's power. Again, that probably comes back to point one. Understanding the question was more about the power and the maths involved rather than assuming certain things about the height of the sun at certain times of the day. And finally, in question 27D, in better responses, students were able to refer to the graph of P of T to indicate a maximum power of 400 when T equals 6 hours. A good graph in part A tended to make this a much easier question to complete, but then to conclude that it would take less time to charge at T equals 3 than at T equals 3. Use the maximum turning point perhaps at T equals 6 to compare it to the answer found in part C. There were a few different ways that students could get there. And we wanted students to give a clear and concise answer and not necessarily an essay without mathematics involved. And so we want to make sure that while we are doing a maths exam, that students are answering in a maths way. Well, I do believe that's the end of our section. Thank you for listening if you've made it this far, and I wish you all well as you teach your classes in 2022. Thank you.